This recording is about exponential functions. So this is paired with the lesson that you will do regarding those types of functions. So some of the examples that I'm going to go through are things that you will see in that lesson. So first, they will ask you to complete the table. And so in order to graph anything, we can graph using an XY chart, or table of values is another term for that. So they may give us any type of function, in this case exponential functions, and ask us to complete the table in order to eventually graph it. So here is the function 8 to the x plus 1, and they will give you most of the table. So here's f and here's f of x. So they'll give you this table and they'll ask you to find the missing piece. And so what is happening here is that on the x values, they took -1 and plugged it into the function. So every time that they are doing this, they are taking that function and plugging in that number for x. So notice x is sitting right here. So they plug in -1. So it's 8 to the -1 plus 1. Well, 8 to the -1 is 1/8, and then 1/8 plus 1. But we can do that in a calculator as well and get a decimal of 1.125. They did the same thing with 0. They plugged in 0. 8 to the 0 power is 1, because anything to the 0 power is 1. And then 1 plus 1 is 2. So that's why they got a 2 down below the 0. So they're going to want you to do the same thing with 1/3. 8 to the 1/3 plus 1. And wonder what that's going to give you. So again, you can use your calculator. 8 to the 1/3. If you need to, you can change that to a decimal, or we know that 8 to the 1/3 is really the cube root of 8. Either way works. And so if we look at it as the cube root of 8, we're looking for the number times itself 3 times. That gives us 8, and that number is 2. And then 2 plus 1 is 3. So if we go back to our table, this answer right here should be 3. Next, they may say, what is the value for f of x equals 4 to the 2x minus 100 when x equals 3. So they're asking that same question that we just did, just a little bit differently. So when x is 3, we want to know what is f of x. So instead, they didn't put it in a table this time. And so what we're going to do is we're still going to take this 3 and plug it in where we see x in the function. So we get 4 to the 2 times 3 minus 100. Now, that 2 times 3 is 6, so we get 4 to the 6th power minus 100. And we have to do exponents first, so 4 to the 6th power in your calculator gives us 4,096 minus 100. And so that gives us 3,996. So the value for f of x when x is 3, that value is 3,996. The next one, the domain is all real numbers. So all real numbers mean we could pick any number. What is the range of f of x equals 4 to the 2x minus 100? So domain, remember, is all the inputs, and that's related to the x values in a graph. The range is related to the y values, the output. So when we look at that same function, f of x equals 4 to the 2x minus 100, if they tell us that we could plug any number in for x, so that means we can plug in negative numbers, we can plug in 0, we can plug in positive numbers, we can even plug in fractions and decimals. And so if we do that, what is the range of this function? What values are going to come out of there? And so as we look at plugging in these types of numbers, we actually might want to graph this to see what that looks like. So if I pick some of those values for x and I make a chart just like we did on the first one, we can pick some numbers and then plot those points on a graph to see what that looks like. So I'll let you do that on your own, but what you will find out is that this graph looks like this. And so this number down here is negative $100. So as we look at this graph, what we can tell is how low does it go? And it goes to negative 100. And then how high does it go? Well, as we can see with the arrow, it goes on forever. So it goes all the way to infinity. So the range is anywhere from negative 100 to infinity. Okay, now we want to look at another problem where we actually graph a function. So let's see how we actually graph a function. So f of x equals 3 to the x. So we want to, again, make a table of values, or a chart, however we want to describe it. And we get to pick any numbers that we want for, or to use. And so the thing about picking numbers is that the smaller numbers, the easier to compute it, so you might not need your calculator as much, and it keeps your graph a little small. You don't have to make it as big, like the last one that went all the way to negative 100. So in this case, I like to pick some negative and some positive. So I'm going to pick negative 2, negative 1, 0, 1, and 2. And we're going to plug them in. So this is 3 to the negative 2 power. Now remember, with negative exponents, that's really 1 over 3 squared. And 3 squared is 9, so this is 1/9. Plugging in negative 1, 3 to the negative 1 is 1 over 3 to the first power, or 1/3. If I plug in 0, anything to the 0 power is 1. Then I plug in 1. 3 to the first power is 3, and 3 squared is 9. So now I have these points on for my graph. These become the points that I'm going to use. So 1 point is -2 1/9. 1 point is -1 1/3. And then I have 0, 1, I have 1, 3, and I have 2, 9. So let's see what that looks like on our graph. Okay, so we want to plot these points. Now, the 1/9 and the 1/3, if it helps you to look at that as a decimal to know where that goes, that's totally fine as well. So -2 1/9 is going to be pretty close to the x-axis, right here at -2. -1 1/3 is still going to be close, but maybe a little bit higher than the other one. And then we have 0, 1, which is right here. And then 1, 3, and 2, 9, which is way up here. Then we play connect the dots. So that is what this looks like. So we have graphed it. Now notice that if I were to continue and make more points to the left side as it goes smaller and smaller and smaller, will it ever get to be 0? And the answer is no. And so what they call that is it's like it goes closer and closer to an imaginary line and never actually crosses that, and that's called an asymptote. So if I look to see what that asymptote line equation is, we know that it is at y equals 0. Because notice, if I were to graph points on that line, the x-axis, y is 0. I don't go up or down. In addition, there actually is a second asymptote, and it ends up I don't think we need to talk about that one at this point. So sometimes there's another asymptote, but here, for the most part, this is the main one that they're talking about in your assignment. Okay, there is a particular number that you will encounter now, and that just like when we encountered pi, and knowing that pi is actually a decimal number that never ends and never repeats, and it goes on and on and on. There's another number that's kind of like that, and we call it e. And E is an interesting number that occurs just like pi in things that we do. And so we need to know about it because it appears in some formulas that we're going to be using. So I wanted to make sure that you understood that E is just another number kind of like pi, where it's a never-ending, never-repeating decimal. It does occur in things that we do. So the thing that they talk about in your lesson is interest. So in an account, like a bank account or a savings account, there's an interest rate associated with that. And what that means is that you put so much money in the bank, but you also are going to start making some money from the bank. And that is in that word interest. Now, it's not always very much money, but it is something, and it does help your money to grow. And so that interest is paid to you. So they accumulate and keep track of how much interest you will get in the year. And then at the end of that year, then they actually take that money, put it into your account. So now your balance is higher. And then now that higher balance accumulates the interest for the next year and so on. Now sometimes that interest is paid more than once a year. So if it's once a year, they usually use the word annually. If it's paid more than annually, sometimes it's paid twice a year, and so that would be semi-annually. And sometimes it's paid 4 times a year, and that's quarterly. They can also pay monthly, things like that. It just depends on the bank account. Sometimes they pay interest continuously. So that means every time your money is making that interest, it's getting paid to you. And so we also want to be able to figure out how much money we're going to have in our account after a specific amount of time. So if it is compound interest, so compound meaning that's how many times they pay you, compound interest. So they will say compounded quarterly or compounded annually. Compound interest, the formula you're going to use is A equals P times 1 plus R over N to the NT power. So where do all these letters go? Well, A is the future value. So if you are looking to put money into an account, you want to know, okay, I'm going to keep my money in this account for 5 years. How much money will I have? So the answer to that question goes in the A. Now the money you start out with that you put into the account is P. That's the principal. So if you say, well, I'm going to start out by putting $500 in the account, and that would be your principal. R is the interest rate. And we never actually use it. Interest rate's a percentage, but we never use it like that. We want to use it as a decimal. N is how many times that interest is compounding. So if it says quarterly, then we would put 4 in for N. And we put it in both places. And T is time. And it's always in years. So that's where we go and we plug in everything. Now the equation you would work with for compounding continuously is a little different because it uses that E number. So this was A equals PE to the RT. So E is that number, and there is a button on your calculator that is the E button. It'll either just be E or it'll be E to the X. Either way, that's the button you're going to want to use when you're computing these numbers. Again, P is the principal, R is the rate as a decimal, and T is time in years. So I just wanted to explain those a little bit so that you understood what the pieces were to those formulas you're going to be using. So for example, they may say you want to invest $2,000 into an account that is compounded annually and they just at 5%. Sorry, forgot that part. 5% interest. And they want you to determine the equation for how much money would be in the account after T years. So we would use that same formula that we just saw. And so we would have A equals, our P is 2,000 times 1 plus, now our interest rate is 5%, but if we change that to a decimal, it's 0.05. and n is how many times it's compounded. So compounded annually means it's once per year, so that's over 1. And then we have that 1 times t, because they wanted to know how much after t years. So let's condense this a little bit. So a equals 2,000 times 1 plus 0.05 to the t power. We could condense that a little more. And that would be our equation they're looking for. So if they were to actually tell us what t was, like how many years, then we could plug that in and then we could actually compute that answer and find out how much money is in the account. If that same problem was compounded continuously, our equation would look a little different. We would have a equals 2,000 e to the 0.05 t. All right, next, they might give us a table to work with related to some sort of application, time t and the temperature y, and give us some points to work with. Running out of room a little bit. Okay, so here's our chart. Time t over the temperature y. And so 0 time has gone by and the temperature was 200. 1 minute has gone by and the temperature is 150. 2 has gone down and the temperature is 2 minutes have gone by and the temperature is 112.5. 3 minutes have gone by and the temperature is 84.375. What they will ask us is to find some sort of equation. So how do we do that? Let's look at what we are given here. So when we plugged in 0, now we have to remember we're dealing with an exponential equation. So usually that exponent is our variable. So this would be our t. So what happens is if we look at this, we start with that first information and they plugged in 0. So that means anything to the 0 power is 1. And so if anything to the 0 power is 1, they got 200. So that means that they are going to have 200 times something to the x power. Because if they plug in that 0 where the x is, that got 1. 1 times 200 would be 200. Now we have to look and see how did they get that number, because notice when they plug in 1 they get 150. So when they plug in 1, anything to the 1 power is itself. And so, but we also have this multiplied by 200. So our question we are asking ourselves is, what times 200 equals 150? So 200 times what equals 150? And so we could create an equation, but realistically we're dividing. 150 divided by 200. And so when we do that, we actually get 3/4 if we wanted to reduce it as a fraction, or 0.75. Now, could we check our equation to make sure that it works? And the answer is yes, we could. If we plug in 1, we should get 150. If we plug in 2, and I used x and we should use t, sorry about that. Plug in 2, we should get 112.5. If we plug in 3, we should get 84.375. And if those all work, then this is indeed our equation. Some other application problems that are that we would use that involve exponents is exponential growth and exponential decay. Exponential growth is the function f of x equals a times 1 plus r to the x power. Now a is going to be some sort of starting point, some sort of number. So they may say bacteria, and you had 500 bacteria to start with. That would be your a. R would be a rate, again as a decimal, and then x, for amount of time usually. How would I know, so that's exponential growth, how would I know that it's exponential decay? So it's very similar to this one, but we know that it's going to go down because decay means to decrease. So if I was looking at an actual function that they gave me, to know that it was exponential decay, the base of the exponent would be between 0 and 1. So for example, if I had f of x equals 1/2 to the x, then this would be exponential decay because this number is the base of the exponent and it's between 0 and 1. Otherwise, if it's a whole number, then it would be exponential growth. So that's it. Well, now that you've watched this recording, you will either give me a call, text, or message me so I can ask you a couple questions regarding this recording, and you'll get credit for that assignment. Have a great day.